All right, let's look at pretty much the main idea for this entire unit is to get us to a point where we can really investigate these periodic functions. Okay, so I've got a definition here. I'm just going to encourage you to pause it right now and write this down. Okay, and then we can explain it. Pause. Okay, so periodic functions are specific types of functions that have repetitive behavior. Something that's periodic is something that happens over a certain period of time and then it repeats. Okay, so this is saying functions that have a specific domain over which their inputs are unique. After the end of the period, the outputs begin to repeat. Okay, and so the most common periodic functions are usually based on sine and cosine functions, okay, which you'll see here on the next slide. But a different way to think about what periodic functions are, a different way of stating what was written there, is that there are no unique coordinates of this unit circle that exist once we've rotated beyond 2 pi radians. So in other words, when we're doing a function, and I don't want to put the cart before the horse here, but eventually we're going to be talking about functions that are just to evaluate sine x. Okay, and if you think about all of the outputs, or let's say the inputs for that matter, for sine, they're all angles. So as we move around the unit circle to all of these angles, right, we have all of these different outputs. So the sine of 30 degrees is the y coordinate at 1/2. The sine of 45 degrees is the y coordinate, radical 2/2. The sine of 60 degrees, radical 3/2, so on and so forth, and we keep going around. Now, at this point, we would have talked a lot about coterminal angles. Once we get to here and we've made that one full rotation, we've seen all of the possible outputs of sine, right? We've seen all of the top coordinates and all of the bottom coordinates. So all the positive y values are up here and all of the negative y values are up here. And once we go past 2 pi, so we make that full rotation, then we keep going, right? So this angle is coterminal with 13 pi over 6. Okay, think about that. If we make one full rotation, which is 12 pi over 6, and then we go up to pi over 6, right? This angle is also 13 pi over 6. But the output for that, we've already seen once before at pi over 6. So nothing is unique once we go around one time. So what we say, therefore, is the period of sine is 2 pi. After you get past 2 pi radians, all of the outputs are the same, okay? A different way to look at this, I've got a graph of a sine wave here. Now I've altered it just slightly, okay? But a basic run-of-the-mill sine wave will start at 0, it'll go up, it'll come down, and we're going to talk a whole bunch about sine waves. I just want to give you an example of what I'm talking about. And once we get back to this spot right here, okay, we can basically take this graph and copy and paste it. Okay. And then you get the next part. So you see how the graph is repetitive. Okay. So this is the period of one sine wave. And if you notice how long it takes, what I've done here is if you look at the X scale, look at where this graph gets to the end of its period right here. Okay, here's 6. Here's where X is 7. Here's where X is 8. What do you suppose that point is right there? Right, that's an X coordinate of approximately 6.28, which is, of course, 2 pi. So we see starting at 0 and going through all of these X coordinates. These are all of the angles. Again, we're going to talk a whole bunch about sine in the future. Just wanted to give you an illustration of what we mean when we say something is periodic. Okay, so use this video as an explanation of what we mean when we talk about the period. It's a unit of time which we can add or subtract and still end up in the same place because the output isn't any different now than it was before at that spot. Okay, It's kind of a loose definition for what we're going to be doing going forward. So take a look at the next couple of videos. You'll see what we're talking about.